Yeah, welcome to the Gnosis Validator Meetup with the Shutter Network. This is a 23rd edition in the whole Gnosis Validator Meetup history, so which is crazy. In this call, I try to briefly summarize. I will share some updates on the Gnosis chain. Then I will hand over it over to Debjit, who will share core development updates and the client updates on Gnosis chain. And finally, Luis from Shutter will share updates about the Shutterized Gnosis Chain, shielded trading, Shutter Hongbao, which is crazy nice campaign. And then we will have some sort of a question and answer session. If you are ready, let's begin. As you know, I have no any presentation today because I have just a few updates. Firstly, as you know, our preparation of Pectra are continuing. The Pectra hard fork date for the Chiado and the mainnet is not finalized, but we are following the same schedule as Ethereum. It is estimated to take place at end of the February in Chiado and the first week of March on the Gnosis chain. For the stay up to date, please follow our communication channels. This includes, of course, Discord, Validator newsletter, core developer updates on YouTube, and Twitter, of course, is the newest name is X. I will share our main communication channels on the chat box after the call. Please check it out, and please subscribe our channels if you don't have yet. Another update is about the OBOL DVT testing process. We have started the second phase of DVT testing, and in this testing purpose, we are working with the Hopper, Nethermind, Gateway, and the DV Labs. I hope we will get a good result soon, and we will share the results documentation and results analyze after the testing phase. And you can see some details over here, and you can subscribe to our Validator specific newsletter. Another update, of course, the Shudder Network package. Shudder Network package is now available on Dapp Store. I'm sure Luis will share more details about this release. Basically, you can download the Shutter package on the Dapp Store. It's a very straightforward process. And if you have any questions, if you want to become a keeper operator on Shutter, please ask any questions if you have. Luis over here. It's a great time to talk with him. And finally, there are two more updates that are still in the progress and not ready yet, but I want to share with you. We have reviewed the contract that allows one-click transfer of Validator rewards to the Gnosis Pay card. To the first example of which was prepared our very valuable validator, Howrock, and right now we audited this contract and improve it, and right now we are finally in the design process to integrate it into the deposit UI. After this implementation, your validator rewards with this with this contract, you can send your validator rewards into your Gnosis Pay card with a EUROE. So we are abstracting all the claim and the exchange process. Of course, it depends on your amount. Like you can pick some amounts, or we can pick some dates and the frequency on the UI. So it's pretty nice. It's a good example of our validators also can spend their rewards into the real life with this contract. And the final one is we also forked the each staker deposit command line and made it compatible with the Gnosis chain and the Chiado. There are very minor optimization left, but after the final change, we will make it available and add it to our documentation and share it with you on all channels. Of course, we are working with the each staker team and the whole process. They know, they are aware of it, and they are also supporting us in many way. So I thank them. I would like to thank its Staker team for this amazing cooperation. Yeah, that's all my updates. I will hand over to the Debjit, who will talk about client implementation and the core developments of Gnosis Chain. Hey Deb.
Hello, hello. Am I audible?
Yes, we can hear you.
Nice. So before I go into the client updates, I just want to say in short some of the EIPs that are going into Pectra, and after that, maybe I'll talk about how Gnosis Chain is different from differing in some of the EIPs, and finally the client updates. I mean, and also the order in which I'm gonna say is my personal favorite. So the best one, according to me, is EIP 7702, which is about externally owned accounts. That is, you can set code in an EOA. You can not actually set code. You can set something called the delegation designation, which is the what addresses code will be executed. So this is very good because you can do all sorts of things like transaction batching, sponsored transactions, even conditional transactions. For example, you can give sub keys of your account to some people and set a limit so they can only spend some types of tokens or they can spend maximum 10% of the balance, stuff like that. So the next one is, I think, the most important for the CL, the consensus layer, that is 7251, which increases the max CB. So, right now there are around 1.2 million validators and the P2P network overhead is a lot. So doing this will allow many big validators to consolidate into single ones, with up to 2048 ETH, and that will hopefully bring down the P2P, the traffic down by a lot. Uh, the next one is 2935, which is about serving historical block from the state, which earlier we were not able to do. And it has some short-term benefits, but mostly it's a prerequisite for Verkle. There are some then seven six then like general purpose execution layer withdrawals, EL triggerable withdrawals, all sorts of things. And there are some kind of old EIPs which are finally going in. For example, the precompile for the BLS curve operations. Then three others. One is just about supplying validator deposits on chain. Currently, the CL, like when you make a deposit for the validator, the CL has to do an additional round of verification, which is actually a relic from pre-merge times. So currently we don't need that, and that will we are doing away with it with EIP 6110, and it will hopefully bring down your from the point you deposit till the point your validator actually gets active. It will bring that down by a lot. Um, then two other ones. One is the moving committee index outside attestation, that is refactoring change, and the second one is uncoupling the blob count between the EL and CL. So these are all the EIPs that are going into Pectra. Some stuff like EOF, PRDAS have been decidedly taken out of Pectra. And with that, I'll talk about how we are doing it in the Gnosis chain. We only differ in two EIPs, actually. One is the blob throughput, that is the 7691, where some of the constants are modified because we have a very different approach to blobs. That is, since our chain fees are already so low, our blob fees are kind of higher so that it prevents network spamming and all sorts of things. The second issue, which is not an EIP in mainnet in Ethereum, but it's a modification of an EIP only for Gnosis chain. That is, earlier the blob gas was getting burnt. Currently, after Pectra, we'll be collecting it in the fee collector address, which is also what we do for the base fee, uh, which is also burnt on mainnet, but in Gnosis chain, we are collecting it in the fee collector. Uh, on client updates, Get, we are so happy to announce that Get has released last week. Uh, currently it is not Pectra ready, but we'll get there in like way before Pectra. So no worries on that. Reth is also getting developed very fast. So currently, like we had several issues with the P2P layer. Currently, those are fixed, and currently we are working on some Cancun bugs, and after that, Pectra. Pectra will be kind of easier to implement on Reth, but the Cancun bugs might take some time. Yeah, if we do that, we'll be up to 4 on client diversity. That is it from my side. Yeah, Arman, take it over.
Thank you, Deb. Thank you for the great updates. Yeah, if you have any questions, please drop it, leave it on the chat to the Deb. Yeah, right now we are going to do Luis.
Oh, yeah, sorry. Yeah, thank you so much for having me. If you don't know me yet, I'm Luis from Shutter Network, product leader Shutter Network. So working with BrainBot, which is kind of the one of the core contributors to Shutter. And Shutter is essentially a threshold encryption DKG. Um, so encryption and decryption in a decentralized way, and we have this keeper set, which they collaborate to generate encryption and decryption keys. And for this, and we have it, for example, one use case is shielded voting, which is implemented into Snapshot. So if you have a Snapshot DAO, switch it on, and you can have temporarily encrypted voting during the Snapshot vote. But for this Validator meetup, obviously more relevant is the our collaboration with Gnosis and Nethermind, which is the sort of mempool privacy encrypted mempool solution we've built together with these with all three using threshold encryption. So we call it an encrypted mempool on Gnosis chain, which means transactions can be sent encrypted. Ideally, the user encrypts them in their app or in their wallet or in the front end, sends it to the validators, and we have a specialized Nethermind build which accepts these transactions, these encrypted transactions. So the validators commit to inclusion of these transactions while they're still encrypted. And only after this do the decentralized keeper network release the decryption keys, and only then will it be decrypted. And what does that help with? Or I mean, yeah, the whole point is we have a lot more information symmetry, and we have front-running resistance and malicious MEV resistance and real-time censorship resistance. Maybe just a quick sort of explain again why this matters is that currently, as Ethereum stands today, and as all public blockchains stand today, uh, they sort of solved transaction ordering on the timescales of 10 seconds or half a minute, or even in Bitcoin it's higher, right? Like on the order of minutes. So that's kind of one of the key innovations that we have fair transaction ordering. Satoshi in the Bitcoin white paper talks about the clock. Essentially, it is a clock that orders transactions. The blockchain is a clock that orders transactions, which is great for these. We solved it for the larger timescales, but we have not for shorter timescales. Right. So the shorter you go to the timescale, the more you see that it is no longer that transaction access to the blockchain and sort of information symmetry, who sees what and who has an information advantage, is not solved and is not decentralized and is not fair. So depending on who you are, let's say you are a validator, or let's say you are a sophisticated MEV searcher who somehow has prioritized network access to the network, it means you can have significant information advantage seeing other people's trades essentially before other people, and that allows you to leverage that information and trade on top of it and exploit other users, right? So in a way, information advantage is everything in trading, right? That's the reason you trade, is because you think you know something that the others don't, essentially. And it's important that everyone has the same access to the transaction infrastructure, because if you don't, it just sort of causes chaos, and that's what is happening. It causes chaos, right? We have a lot of MEV front running on Ethereum. We have censorship. So the various transaction supply chain intermediaries on Ethereum mainnet are censoring, right? And so again, sort of that's the problem set, right? Front running, MEV, not equal transaction information symmetry, and builder centralization is a big issue on Ethereum. We only have 2 builders right now, Beaver and Titan, and only those 2 builders build all the blocks essentially. And all of those are, we think the encrypted mempool can help with those issues, right? Because it is one little step towards ensuring that everyone has the same level of information when they trade, because we encrypt everything and we decrypt everything at the same time. Basically, that's sort of the gist of, again, the encrypted mempool. And again, we built it with Nethermind and Gnosis. Launched it a couple of months ago. Share my screen actually, and I'll just share sort of it in action, right? That is kind of our dashboard here. And you see the amount of shielded transactions so far, the amount of Shutterized validators, still quite low in terms of percentage, because we're still kind of ironing out some minor stability issues, but it's been improving a lot over the last couple of months. And these are the keepers. Currently, only 7 are running for Gnosis Chain, but we also plan to increase this number very shortly. And then you can see here kind of it in action. So maybe we can actually kind of do a live demo. I'm not sure if this will work. Essentially,
That will be awesome.
let's try. So I have a little spammer. I'm not sure. Let's use the spammer.
Yeah, I mean, we can also organize another call if you
Yeah,
are not
let's see.
comfortable.
So here I built just
Oh,
a
yeah.
little dumb spammer, which sends transactions between these amounts in random time intervals, right? And it can either use the shutterized encrypted RPC or it doesn't. And so let me launch it, and then we can see down here, boom, transaction sent. And then ideally we should see them pop up here. And then share. The Explorer, we share. Yeah, then you see then 2 seconds ago, now these transactions are coming in. So these are still encrypted. So the sequencer sort of notifies us that there's been encrypted transactions. And because we don't have because we only have 3% of the Gnosis chain validators are shutterized, it'll take a while for a shutterized validator to pick them up, right? So now they're encrypted and they are waiting for a shutterized validator to pick them up, and then they'll appear here essentially. And if you see one here, essentially that's how it would look like, right? It is shielded essentially, right? So yeah, and hopefully the easy thing is, yeah, it's as easy as swapping out your RPC for now, and you can get protected. Again, still some issues there because we don't have this high validator percentage, so it'll still take some time, right? For example, right now around 3 minutes, which isn't optimal, especially on Gnosis Chain if you're used to very fast confirmation times. But yeah, and then you can also inspect individual transactions while in flight, essentially. So you could use the transaction hash and check individual transactions. Yeah, so that is the gist of it. Can't really show, I think, the will we be able to see it? No, yeah. So I think yeah, that's the extent of what we can show here, I would say. And then afterwards, they will just appear like a normal transaction, right? So in the afterwards, they will get decrypted, and then they will show up just like a normal transaction. So there's also no yeah, it's not a privacy feature, right? And but that's probably also for the better, right? Because yeah, it is not a tornado cache. It is a transaction information symmetry solution. So yeah, and then just a couple of other updates in regards to Shutter and Gnosis Chain. So I talked about the keepers. So essentially, the way Shutter and on Gnosis Chain works is there are two different groups of nodes sort of that are relevant. One is the keepers. Those are the ones running the threshold encryption committee, which they run the DKG and generate keys. And then the shutterized validators, which are the normal Gnosis validators that can use the Nethermind build um, to register themselves and then receive shutterized transactions. And I'll give updates for both of these groups essentially. So update number one is that the Shutter DAO 0x36 just um, selected a new group of keepers, which is this group of keepers. So this is how it works. Essentially, they apply. All keepers apply here to become validators, and then there is a decentralized governance process which votes for them. It uses obviously Shutter shield voting here because it's already planned. Yeah, and then you can see that they were voted on. And someone writing something in the thing. Oh yeah, the links. Okay, I think yeah.
Yeah, I shared on the
Yeah,
how to apply on keepers.
beautiful. Yeah. And then so that's snapshot. So that's off chain. And then what happened was then someone submitted this on chain proposal, which wrote that on chain, and then these keepers are solidified essentially. Um, so that's happened a couple of weeks ago, and now we have this new keeper set confirmed on chain. That being said, uh, it's still really worthwhile, I think, to apply to be a keeper. Two reasons. One is that we haven't really had a good way to judge uptime for the current keeper set. So I think there will be, so we're building a dashboard which will kind of check uptime and performance of these keepers. And my guess is there will be a bunch of keepers who are not performing that well. So it'll be very likely that the DAO will decide to kick some keepers out and to approve new ones. So I think it's still very worthwhile to apply to be a keeper. Um, and so reason number one, because yeah, there will be more keepers approved. And reason number two is or the DAO is expected to launch its initial version of incentives and staking very soon. Um, as a developer house, Blockful, who are also working a lot on ENS, they built the initial kind of staking and incentives mechanism for keepers. So that will mean keepers will need to stake SHU tokens and will receive SHU tokens in reward to running the nodes. And this is the first step towards kind of fully sustainable economics for Shutter, where hopefully at some point we'll have fees for the encryption going into the Shutter keepers, and that'll be yeah, a sustainable revenue model. And this is kind of the first step towards that. Another update in regard to the keepers, and Arman also just touched on that, is that DAppNode now has a package. So if you are whitelisted as a keeper, it means you can easily use your DAppNode and just install the package essentially. Um, that's that's great. Yeah, so DAppNode, I mean, is a great team anyway. And so then just a quick note on validators, right? So this is again if you are a keeper, and this was if you're a keeper, but if you are a Gnosis validator, this is the steps essentially to get to become uh, to to use Shutter. So if you run the latest Nethermind build, you already have the software basically running that allows for this, but you would need to register as a validator here, and there are some scripts that you need to uh, fill out and do, and then you will be a Shutterized validator. And we are also reworking this flow to make it a little more, add a little more details around it, and make the script a little more automated. But yeah, that's kind of the process to do so. Yeah, so that's it, I think, for kind of Shutter keeper, validator updates and all of this. One thing I would love to mention is if you are a validator, also kind of on Ethereum mainnet, especially, we're working on this sort of lengthy document for which outlines a roadmap towards the encrypted mempool on Ethereum as well. So in theory, we could apply the same encrypted mempool as deployed on Gnosis Chain on Ethereum, and that was originally the plan. We had this ETH research post in 2022, also co-authored by Martin from Gnosis. Unfortunately, in the meantime, not sure unfortunately, but essentially in the meantime, Ethereum transaction supply chain changed a lot, and now we have PBS, and we have other changes that make it more difficult to apply the encrypted mempool as is on Ethereum main chain. But what we've done here is we're going to outline really a comprehensive sort of roadmap towards how to do that on main chain, and we'll have kind of 3 steps. Step 1 will be to do the encryption at the RPC level, and this is something that MEV Blocker is very interested in implementing for their fully private transaction flow. So it would mean within MEV Blocker, you would then have an even more private, I would say, transaction route, which uses threshold encryption. Um, that's exciting, I think, in itself. We have an intermediate step, which would mean we could do the encryption and decryption the decryption at the relay level. And then kind of the novelty here of this proposal will be that we will utilize the idea is to utilize proposer commitments for the encrypted mempool. So proposer commitments is this novel sort of primitive or concept that for pre-confirmations especially. So for pre-confirmations, the idea is you can get a pre-confirmation from your proposer to get a transaction included very quickly. But our plan here is, and this is also something that Chainbound, who are building this infrastructure, one of those building the infrastructure, has been collaborating with and have given their ideas here on how this would work via Bolt. So it's the Chainbound Bolt protocol. Would mean to get a proposer commitment to so the user would get a proposer commitment to include their encrypted transactions. And that would be a way in general to make the encrypted mempool compatible with chain. Again, because that's sort of different on Ethereum compared to Gnosis. Yeah. So that's something that I just wanted to tease here a little bit because we're still collaborating on it with Gnosis, Nethermind, MEV Blocker, CowSwap, and Chainbound teams, and we'll be releasing this sort of white paper essentially shortly, and we would hope to get as much support for this as possible because yeah, again, it will require collaboration, it'll require implementation. Yeah, just wanted to tease this a little bit. And then last but not least, Aman also hinted at this, is essentially a little hack slash joke that we deploy within sort of like just hack this together within a week to build a little threshold encrypted use case essentially, and this is also deployed on Gnosis Chain, and also uses um, an on-chain deployment essentially of Shutter deployed on Gnosis Chain. gifting dApp. So if you're not familiar with Hongbaos or Angpaos, they're called in different countries in Asia, it is a red envelope which is used to gift primarily money or things of value. For example, for Chinese New Year, Lunar New Year, which is in 2 days, 29th. Also used at weddings and other instances, but essentially this is a way to give a digital version of this, and it is time locked. So you can choose sort of you can create an amount here, and you can choose the time. So you could do just right now. You could do Lunar New Year, but let's do 1 minute so that it actually works, and then you can create it with 1 second. Let me do something here with my MetaMask. Let's do this again. Just 1 second. Like this. Fund your Hongbao. Like this. Creates this link, and this is sort of a little hack here that essentially it funds a one-time private key, which so the one-time private key holds the funds in flight essentially, so that the receiver can receive this without owning crypto or without having an address in the first place, right? So you can send this link to anyone who doesn't have crypto or even doesn't have a wallet, because we have a uh, passkey wallet which can claim, and this can use your fingerprint. So yeah, and then the special thing is it's threshold encrypted with Shutter, and it just now unlocked essentially. Maybe we can see in the console more details of what actually happened. Yeah, so this is and we can see here. Let me refresh that it unlocks. So it received the Shutter decryption key here, and called this API function, to receive the key, and then locally decrypted the Hongbao once the time was up. And now you can claim it to any wallet. Yeah, so and that's the whole point is here. Let me do that actually right now, and then explain afterwards. So claim to new wallet means you can claim it to a new passkey wallet, which means again you don't need MetaMask, you don't need any wallet beforehand. It'll create a wallet for you that'll live in your browser. Actually, yeah, let's do that. I think that's better. Oh no, we do. I already have a wallet, right? So let's do claim to an existing wallet. This one. And then it is trying to claim it. Hongbao redeemed, funds have been transferred to your wallet. Funds transferred, and it swept this private key, and now it's here on my little wallet, which I need to switch here. Boom. So here I can load it again from a passkey, and it arrived here essentially safely. So yeah, the whole point is this a little demo to show sort of the power of time lock encryption, and decentralized time lock encryption, right? Via threshold encryption, so you can encrypt something with a Shutter public key, and you can designate a time in the future and have it be decrypted at that point in the future. And because again we're using threshold encryption and this decentralized keeper set, you can be reasonably sure that it'll stay secure, because you always need a high number of these keepers to collaborate before they can actually decrypt. And B, you can be sure that it will definitely get decrypted. So if you compare against something where you encrypt yourself and then decrypt yourself, A, you would have to do the second action, right, to actually decrypt. That's kind of annoying. And B, you can never be sure that it will be 100% decrypted, so it's kind of a forced decryption, which, yeah, depending on the use case, be very useful, right? Yeah, so it would be awesome if anyone who's interested sends creates a Hongbao and sends it around. Let me create a new one just for the chat here, and we can see who's first essentially. And we do a little race. Let's see who's first to decrypt, to claim.
Of course, first come, first serve.
First come, first serve. Exactly.
I have questions to Luis. For the very basic questions about becoming a keeper. What is the hardware requirements, and what is the basic system requirements for becoming a keeper?
Very lightweight. So I don't even know. Essentially, it is so lightweight that the defining factor will always be the node that you need to run in parallel. So you will need to run the Gnosis node besides it, right? So so that will be the defining factor, kind of. So the node itself, kind of, you could probably get away with kind of like a one CPU, I don't know, 8 GB, 4 GB RAM droplet, or a Raspberry Pi even if you wanted to. Again, but you'll probably want to run this on the machine that also has Gnosis Validator. So like a dApp node is perfect. Yeah.
Thank you. If you have any questions, please leave the comment, leave the chat box here.
And while people are eventually having questions, just to expand on that, that's kind of a very nice property of threshold encryption, that it is so lightweight and that it doesn't require sophisticated machines and hardware. So the alternative to building sort of transaction encryption, right, is people are using TEEs, which then you have these hardware trust assumptions. So you need specialized, more expensive sort of enterprise grade hardware to have a TEE that restricts kind of who can run these things, and again also includes a hardware trust assumption. Or and the other alternative would be, and that's something we're very excited about, but it's really like more in the future, is using really advanced cryptography such as generalized MPC or FHE, fully homomorphic encryption. So that would be really the holy grail going forward, to have fully private Ethereum at some point, right, where the transactions stay encrypted. And for that, you would need something like this. You would need sophisticated cryptography technology, which would allow you to compute over encrypted inputs. And while that's super exciting, and we're sort of following this very closely and are thinking, oh, how can we kind of make it compatible with Shutter, or how can we build our own kind of threshold FHE system? It is also really expensive compute-wise, on the order of kind of making it really infeasible right now for most use cases. So that's really a nice thing about threshold encryption. It does not have to do compute over encrypted data, because it is just the encryption decryption. So it only needs to decrypt, and that makes it extremely lightweight and makes it so that anyone can run it, and not just someone with, let's say, again, either like a TEE or someone with probably people are running these FHE things. They'll probably require sort of like an advanced NVIDIA H100 or something to get reasonable performance, in the tens of thousands of US dollars, right? So that's a great question about the keeper requirements, but I think it also hints at this bigger topic. At threshold encryption is actually a very nice cryptographic primitive, because it's accessible to anyone, and you don't need to have extremely sophisticated hardware.
I absolutely agree. Absolutely agree with this approach. Yeah, we are heading to time, and It's the last call for any questions. If not, I will close this event. Next meeting will happen at the February, which will be all about the Pectra. And thank you for joining. Thank you for participating in this event. Thank you, Luis, for providing a very comprehensive details about the Shutter and the Shutter updates. Oh yeah, I have a question, please. Yes, we are listening. One oh. Yeah, let me share with you. I'll share with you all about our communication channels, and this place is our newsletter, and you can follow all the updates over here. Please subscribe it, and also you can every time just leave your message on the Gnosis Validator channel in the Discord, Gnosis Discord. Chim is over here, me always checking the all message. Yeah, it has to do setting up a Gnosis dev node in Ghana for HQ. I'm sorry, it might not be related to yeah. You can drop it on the comment section and we can discuss later. Yeah, thank you for participating this call. Happy to chat on chain.
Thank you so much for having me.
Thank you, Luis.
Bye.
Bye. Oh, okay, guys.